All right. For everyone who's still attending for the Hackathon Recap, thank you for being here. I wanted to give you a quick recap of what we did this Sunday at the hackathon that we organized. I don't want to take too much time because there is a lot of things that the winning teams would like to present. So I'll probably take only 5 minutes to give you context of what we had done, what was the entire environment all about, and what the goals were primarily. So for those of you who are in the know-how of the hackathons that we've been organizing as well as participating in at NANOG, this is actually the 6th hackathon that is being organized, and all of the ones that have been done earlier were by several other vendors and combinations of other operators that are available in this field. So one of the main things we wanted to address as part of this particular hackathon is that we've slowly started evolving the goals of what the hackathon is meant to be. All of the things that are involved in the infrastructure as well as the goals of the participants themselves. And being a participant at the hackathons for the first few times myself, I had some context of things that we had done earlier, and therefore we wanted to incorporate some of the learnings from that and try and change what we can do, hopefully, this time to encourage more participation and hopefully look at more of the things that are available within the industry. So our primary focus at this juncture was to make sure that we focus on operations, network operations, which is certainly the strong suit of most people participating at NANOG, and therefore it allowed us to take a look at all of the different APIs and tools that are available for us to incorporate as part of the hackathon. Now, one of the things that we did try and make sure this time is that we had greater focus on pre-staged topologies and documentation that hackathon participants can have access to as part of the hackathon. And this gives them clearly an opportunity to utilize a large set of tools from the outset because it's available to them as part of the infrastructure. We had seen in earlier hackathons that not providing an infrastructure leads them to either fend for themselves or figure out a lower utilization of tools than would be more appropriate. So we certainly saw a lot of different participants come in and they were able to utilize most of the tools available and even build more things on top, and you'll actually see what they built in just a bit. Also, we made sure that everything is public. So if you want to take a look at things that were made available in terms of the topology, the code that was provided to the participants, things that they could utilize beforehand and then build on top, everything is at the link there, right? So it will point you to both all the GitHub repositories, the website content that hosts this as well. This was organized primarily as a partnership between Cisco and Tessuto. And Cisco providing, of course, the network operating system, which was iOS XR, and Tessuto providing the infrastructure, which is hosted on top of Google Cloud and uses their entire platform and APIs to be able to orchestrate it for all the teams that were involved. This is the topology we ran with, and I'm sure the teams will give you further context on this. 3 Linux development instances per team. So each team has access to a pod with all of the instances shown here. And there are 4 iOS XR instances. We went with iOS XR primarily because of all the APIs and tools we wanted to use, and it fit the bill in terms of support and capability. So this is a quick snapshot of that. And of course, the basic premise, which is we split up the team into 3 primary categories based on the days of operations that we wanted them to focus on. So every team basically set out to try and automate each particular day, as you can see, starting from zero-touch provisioning to Ansible-based orchestration using YDK, GNMI, and OpenR as a set of tools available, to going even with traffic engineering using the gRibai APIs in the OpenConfig consortium, right? So there's a huge variety of tools and APIs that we wanted them to take a look at, and I think a lot of them were successful in incorporating them as part of their code and then doing more on top. And I'd like to quickly give you some highlights. I've been actually told that the first statement might not be entirely accurate, but it was certainly one of the more heavily attended hackathons we've had in a while. And with around 70 odd participants on and off throughout the day, which certainly gave us a lot of both participation, feedback, as well as incorporation of things that we'd like to do for further hackathons in the future. There were several students from universities that participated. In fact, the team that won second place is from a university as well, and they'll recount their experience. And we had web and service provider participation, as we always do. Several first-timers, as always, which implies that there is always room for more. So folks who haven't actually tried to tread into the world of hackathons and trying to code something up, please feel free to participate, at least from next time. We have people who've either never coded before or never participated in hackathons before coming in on most of these Sundays before the NANOG. So it's a good experience, and I think the teams will sort of give you more insight into that. So that's it from my side, and I'd like to actually invite the team that won first place, pod number 10.
Thanks everybody for sticking around. My name is Adam Mills from Roblox. I'm the designated representative from ID Pod 10T. What was really great about this hackathon, and my hat's off to Cisco and to Sudo for getting all the infrastructure ready. This was my third hackathon, and this was without a doubt the easiest to get into the tooling to actually start programming. Our team consisted of a number of different people from different varying backgrounds, which was great. There were some beginners, some intermediates, and some advanced network engineers and software programmers. Everybody was willing to chip in and help anybody who had questions, and everybody on our pod participated in some way in making the hack work. And so we've already gone over the hack goals, which was the day zero with the ZTP configuration, to generate streaming telemetry and updating an Ansible playbook to work for that, and then to inject LSPs into the devices to try to manipulate the traffic based on the telemetry that is being received. Again, just a recap on the topology. So I'm going to hand it off to Mercy, and she's going to talk about the goals of the Day Zero group.
Hi, my name is Mercy. I'm a student at Ball State University. For Day Zero, we had the fundamental framework already set up. So our responsibility was to take the ZTP Python script and update it to configure not only the name, but also the interfaces and the LLDP using the OpenConfig Yang model. We also modified the script to recognize which of the 4 routers was being configured by the script. And just like every other team, my team had a bit of an issue getting the open model to work. So we found out that using the, okay, thank you. We found out that using the, vendor-specific data model actually works better and makes it a lot easier for us to accomplish the task. After we were able to determine which config was for which device, we had to use Python to load the config on the box and then commit the config, which made it possible for the part of the team that worked on day one to actually take over. Before I hand off to Damien, who is going to take us on day one, I want to use this opportunity to say thank you for this great opportunity. I learned a lot and I grew. Thank you so much.
So for what we call day one, the goal was to turn on all the BGP configurations, and the requirement was to only use OpenConfig interface. So the team had to come up with the Python code that will load the Yang models and be able to do that, and have then an integration and package that as an Ansible module. So we were able to do all of that. As part also of this exercise, we had to use OpenR, and so for me and the team, so it was interesting to see that we could use Docker running on iOS XR, and OpenR was running inside Docker. We also took some time to investigate how we could use the native Ansible modules to do that. So we were actually able to, since iOS 6R is really like a Linux platform, be able to leverage, as you can see here, the native Ansible Docker container package. And all this integration actually turned out really well. We also had some work around GNMI, but that's something we'll explain later in the presentation. Thanks.
So the goal of day 2 was to create a controller and use that controller to inject routes into the device rib and MPLS database. So all the routers that you see here on the screens, they're streaming telemetry to a Kafka bus, which was set up by the day 1 team, and we set up a parser that's listening in on the same Kafka bus, listening for failures and injecting routes and creating LSPs based on network availability. So the topology that we have here is we have 4 routers and 2 hosts, dev 1 and dev 2. So traffic from dev 1 to dev 2 first hits router 1, and then from there there's 5 available paths. The most preferred one is path 2, which is the green path you see on the screen. So that's straight through between R1 and R4. For some reason, if that path isn't available, then traffic will go over the top, over R2, and take path 1, or it might take R3 over the bottom and be routed that way. For some reason, if path 1 and path 3 both are not available, then traffic will trombone and take path 4 or path 5. Just by showing hands, how many people are familiar with or have heard of GRB or G-RABA, depending on how you like to pronounce it? Okay, so few people, all right. So RABI stands for Routing Information Based Interface. It's an API that defines a standard interface for injecting routes into the device rib and the MPLS database. So all the routers that you see in the topology, they're all exposing northbound API. And we have a Ruby client which resides on the controller that talks to the devices over gRPC channels. One thing I wanted to mention also actually on the previous slide, unlike OpenFlow and other mechanisms which try to program the forwarding plane directly, GRB does not interact with the forwarding plane or with the FIB. It interacts with the control plane, so all the interaction is with the RIB and the MPLS database. So think of it as just another routing instance or another routing database that live alongside your IGP or MPLS database. The abstraction is, the API abstraction is done through JSON representations, and we're just showing all the JSON files that we've used in this topology. These are the files that the parser executes and to create LSPs across the network. So one JSON template per router per LSP, and if you were to open one of those JSON files and look what's inside there, you will see that all what we're doing really is just telling the router, hey, go ahead and inject this prefix with this with this next hub and outgoing interface, and do some MPLS label operation. So depending whether the traffic is entering or leaving the network, the router will do push, swap, or pop operation. Then I'll turn it to Antoine to talk next about the parser, and he's going to give you a demo at the end.
Hi, my name is Antoine Delanois from Cloud Temple. So the first step was to, thank you. So the first step was to pre-configure the LSPs with the JSON templates, and the idea was then to go one step ahead and be able to react to day one telemetry data. So we wrote a small Python controller, which is able to read messages from Kafka and to parse them in order to trigger LSP creation and removal on the fly based on interface operational status changes. So we embedded a basic model in the script, a basic model of the network, in order to maintain a snapshot of its state over time. And the idea was whenever an interface change occurs, the event is parsed, and it triggers an update of the model, enable some new paths, and triggering path election over time. We are, speaking of time, we are running out, so we prepared a short demonstration. So here is a macro scheme of what we did on Hackathon's day. We added some little piece of magic with InfluxDB Grafana to visualize what was actually going on in the network. So, yes, the panel. So first, we'll be having whole interfaces up in the network. And then I will cut some interfaces, forcing the traffic to go along path 5. So, yes, okay. So you can see here, we are on dev 2, and we are running a ping towards dev 1. So, is it running actually? Video? No, click again. Yes, okay. So the ping is not working because there's no LSP. I'm running the script, and everything is initialized to down. And as soon as the script discovers new actual network states, it will cheer up the path to LSP. So the ping is working. And the idea is now we will going to see through Grafana that the traffic is throwing between router 1 and router 4. And then we will shut down 3 interfaces, forcing the traffic to flow along path 5. It shall be automatically detected by the script, and according to which path has the best priority or which paths are available, it will fall back to the proper one. Okay, so now we can see that the active LSP is tiered down in order to tier up the proper one. We only have path 5 available. And we will see in Grafana in a few seconds the interface change in traffic. So that's on router 2. Yes. This actually takes a few seconds to refresh. Yes, here we go. So I'm giving the mic to pod 12 for the next session.
Thanks for your time.
Hey everyone, we are Team Buff. We're 6 students from, So we're 6 students, myself Abhinav, Jam, Karthik, Nagendra, Vishali. We are from University of Colorado Boulder, ITP program, and we were joined by Casey from Ball State University. So I'll talk about the challenge first. As Akshat explained, this challenge was focused on automation, right from device provisioning to provision services, and then taking it to traffic engineering. Day 0, day 1, and day 2. Day 0 focused on device provisioning, and once they have their basic configuration and IP set up, day 1 focuses on provisioning different services. And then day 2 takes into account all the basic networking and set up MPLS LSPs for traffic engineering. So this was the topology given to us. It consists of 4 routers, which are Cisco IOS based, 3 Linux devices, 2 dev servers, and 1 ZTPE server, which was a management server for ZTPE, and it was connected to different devices through an out-of-band management network. So getting into the objectives of day 0, we first had to comprehend how ZTP works in the network, and then we had to create XML files which would feed into NC client. And then we had to trigger ZTP to fetch a Python script which would run on the box itself and deploy the predefined configs. The devices that you see here in blue were the 2 devices we were asked by the organizer team to start the day 0 with, and different other devices were being used by different members of the team for different days. So how we went about it was we created an XML format which would be easily fed into the NC client with all the parameters of like interfaces, IP address, hostname, whatever was required. And then we go about fetching the Python script. We point the DHCP server to a Python script, and that fetches the Python script in the box, and the script runs on the box itself and deploys the predefined configuration. So here you see the snapshot of XML file that we created, which was given to the NC client model. Then this is the Python script we created on. So in a for loop, it would fetch all the files for different nodes in the router. And here you see the one line highlighted, the DHCP server pointing it to the Python script for router 2 in this case. And then ZTP finally, once we trigger it, it actually applies the configuration and commits it, and the operation is completed. And that takes us to the basic networking that it has established in the topology. And then we move on to day 1. So day 1 had, so once the IPs and everything was configured, day 1 revolved around provisioning services like BGP, OpenR, and all this using and master Ansible playbook. It used YDK and GNMI APIs, and we then had to deploy OpenR as the IGP, and also set up a telemetry collector which would fetch all the network health information in real time and feed all that information to a Kafka consumer, which would be set up later. So devices here in blue were the devices we started day 1 with. So our dev server and router 1, 3, and 4 to begin with, but eventually we had to incorporate all the devices and run all of the operations on all devices. So how we went about it was we created a Ansible playbook. As you can see, this Ansible playbook had all the BGP configuration, which would be pushed to the topology, and these parameters were being fetched from an Ansible host file. Here you see the YDK code, which used GNMI APIs and gets the parameters as defined in the by the user. So here you see the Ansible playbook actually being run completed, and the play pushes this AS, peer AS, router ID, and so on, whatever was required to push and to run BGP. But once this ran and play was successful, even then the BGP adjacency didn't come up for us. So that was probably because we didn't have the IGP by then. So we then went ahead and deployed OpenR as the IGP. And as soon as we pulled the Docker image on the box, the application routes that you see here on the screen marked started propagating in the topology. And once that happened, the BGP adjacencies came up immediately. So moving on to the third objective of day one, we also had to set up a telemetry server which would fetch the real-time health information from the network and push it to a Kafka consumer. I'll get into this part, which is tied into day two as well. So day two, so once in day 0 and day 1, all the basic networking and interfacing and protocols were pushed. So once we had all that, we had to encompass the entire topology into getting and fetching all the information and establishing MPLS LSPs. So these were the objectives. So we had to understand how gRebuy works, telemetry and OpenConfig, and MPLS LSPs through JSON files, and then finally deploying the telemetry collector and using all that information to modify the LSPs or traffic engineering our paths as and when the network events happen in real time. So these were the paths that were set up. As the organizer team gave us very good documentation and example of a single path and how these APIs work together. And we had to extrapolate all those information to establish other paths. So we established these paths through JSON files, and then we had shell scripts to actually add or delete the paths as and when required by the user. So here on the screen, you look at the left-hand side, you see the JSON file that we created. This had all the information relevant to establish an MPLS LSP that labels, IP address, interface, and so on. And on the right-hand side is the script file, which uses these JSON file to establish LSPs. At this point, we wanted to, we had a Kafka consumer running on Dev 2 as well, and it was retrieving information from the servers established in day 1. And once that happened, we wanted to parse that information to modify and traffic engineering all the LSPs that we had. So for example, if an interface goes down and that LSP path should be teared down, and then we should establish a new LSP without having that interface in the path. So that would have been our future work, but here we see the MPLS. Once the script was run, we could see the MPLS forwarding table with all the relevant labels that we pushed. And once that happened, we had end-to-end connectivity, and ping was successful. So going on to the learnings, all of the tools that were made available to us were new. We had an idea about how automation works, but tools like GNMI, APIs like GNMI, gRebuy, and then deploying OpenR, and that too on a Cisco platform was very cool to see. We didn't use all these tools before, and we had to integrate all of them in a master Ansible playbook to get this working. We're very curious to see what all doors and new ideas and use cases it opens up for the networking world. Also, like, we did all this in a short frame of time, so that was really nice to see that. I'd like to use this opportunity to thank the organizers. It was a great hackathon. Akshat helped a lot during the hackathon, so the team was very supportive, even though the tools were very new to us. I'd like to thank NANOG as well for having us here. Us being students, it's amazing to come here and present at this scale. And also our professors, Kevin Epperson and Dr. Levi Perigo, for accompanying us here and letting us have this opportunity. Thank you very much.